In the early 1950s, actually the late 1940s, they invented carbon dating. We're going to explain a little bit about radiometric dating and how it's supposed to work, and then show you that it does not work, okay? The Earth's atmosphere is about 100 miles thick, and we're also protected by a magnetic field. Radiation from the sun and from the stars, mostly from the sun, goes right through that magnetic field, some of it does, and hits the atmosphere and produces carbon-14. Carbon-14 is radioactive. Normally, carbon is atomic number 6, which gives it atomic weight of 12. But this nitrogen, which is right next door to carbon, gets struck by radiation and it turns it into carbon-14. Now, carbon-14 is unstable. It is radioactive. It's always breaking apart. And you can hear it like with a Geiger counter, you know, click, 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 just like uranium, because it's decaying. They've discovered it decays at a fairly consistent rate. About half of it will decay every 5,730 years. Which means if I gave you a pile of carbon-14, 5,730 years later, half of it would turn back to nitrogen. The rest would still be carbon-14. Theoretically, it's a random event, but it could, that's probably how long it would take. During photosynthesis, plants are breathing in carbon dioxide, and this radioactive carbon is mixed in with the regular carbon. The plant doesn't seem to know or care if it's getting radioactive carbon or regular carbon, it just takes it right in. Animals eat the plants and make it part of their body. Probably during your lifetime, you have either eaten plants or you've eaten animals that have eaten plants. How many have done that before? Okay. So, you probably have radioactive carbon-14 in you. Now, theoretically, what you have in you should match whatever's in the atmosphere, about the same percentage. Because the plants are always breathing this stuff in, and the animals are always eating the plants, and we're always eating the plants and the animals, so it should pretty much stay in balance. It is assumed the ratio of radioactive carbon-14 to normal C12 in the atmosphere would be the same found in living plants and animals. That is an assumption, but it's a reasonable assumption. The atmosphere today is 0.0000765%. Not much. That's how much carbon-14 it has in it. When the plant or animal dies, it stops eating or breathing. How many knew that already? Okay. So whatever it had in it begins to decay. Since half of it will leave in 5,730 years, all you got to do is check to see how much C14 is in it, how much C14 is in the atmosphere, and if it's only got half as much, it's been dead for 5,730 years. Sounds great, but doesn't work. In theory, it never goes to zero, but it goes from a half to a fourth, to an eighth, to a 16th, to a 32nd, to not much, okay? After 4 or 5 half-lives, you can't measure it. So if anybody ever tells you, we know the Earth is millions of years old because of carbon dating, you can rest assured they don't have a clue what they're talking about. Because if it worked, it would only work for 30 or 40 or 50,000 years maximum. They compare the amount of C14 in the object being dated with the amount currently in the atmosphere, and estimate how long the object has been dead. It sounds good, but there are some assumptions that mess everything up, okay? Assumption number 1, has the amount of C14 in the atmosphere always been the same? Has it reached equilibrium? This is an interesting problem. If I told you to fill a barrel with water, but I drilled holes on the other side of the barrel, while you're filling it, it's leaking out. At some point, it's going to be leaking at the same speed you're filling, and that point is called equilibrium. You will never fill the barrel past that point unless you plug the holes or fill faster. See, it's filling and leaking at the same time, sort of like your checkbook. You know, you put it in and it leaks out, okay? Hopefully you want to at least be at equilibrium, okay? If less than that, you're going to be in trouble eventually. See, if your outgo exceeds your income, your upkeep will be your downfall every time. Well, they say if you took a brand new planet Earth and stuck it out in the solar system, the sun would start producing carbon-14. It would start decaying also right away, and it would take about 30,000 years to reach this equilibrium point. Well, Willard Libby and others who invented carbon-14, University of Chicago in 1947 to 53, he got a Nobel Prize for it in there somewhere. He said, well, it would take 30,000 years to reach equilibrium. He said, well, we know the Earth is millions of years old. Mistake number 1. So we can ignore the equilibrium problem. Mistake number 2. The Earth's atmosphere has still not reached equilibrium. There's more C14 now than there was 10 years ago, which proves the Earth is less than 30,000 years old, which I could have told them just from reading my Bible. See, if an animal is still alive, be it plant or animal, okay, it should have about 16 clicks per minute on your Geiger counter per gram. If it's 0 years old, actually 0 years dead. If it's getting only 8 clicks per minute, then it's 5,730 years old. If it's giving you 4 clicks per minute, it's gone through 2 half-lives, it's 11,000 years old. If it's 2 clicks per minute, it's 17,000 years old. This is how they date it. So if you're getting 2.5 clicks per minute, you just find the point on your graph and draw the line over and determine the age. Sounds real simple, but it doesn't work. If we had walked into a room and found a candle burning on the table, and I asked you the question, when was it lit? You say, I don't know, Mr. Hovind, it's burning when I got here. Okay, well then let's do some empirical science. Empirical science is things we can test and measure and observe and test. Not theoretical, I mean empirical. We can measure it and weigh it. Let's measure the height of the candle. Suppose the candle is 7 inches tall. Who can tell me when it was lit? Okay, nobody. Let's do some more empirical science. Let's measure the rate of burn. Suppose we determine it's burning 1 inch an hour. When was it lit? Billions of years ago. You're going to have a hard time telling me unless you're willing to make some assumptions. How tall was it when it started? Oh, we don't have any idea. Has it always burned at the same rate? Oh, we don't know that either, do we? You find a fossil in the dirt, you can measure how much C14 is in it. Very accurately, by the way. And you can measure how fast it's decaying. That's just like measuring the height of your candle and how fast it's burning. Now, when did that animal die? You don't have a clue. Unless you're willing to assume that the C14 when it was alive is the same as we have today, and assume the rate of decay has always been the same down through history. You can't prove either of those. Living mollusk shells were carbon dated at 2,300 years old. Hello, they're still alive. Freshly killed seal carbon dated 1,300 years old. Shells from living snails carbon dated 27,000 years old. That's stupid. He's still alive, okay? I know snails are slow, but 27,000 years, he'd be dead, okay? One part of a mammoth is 29,000 years old, another part's 44,000. One part of Dima was 40,000 years old, another part was 26,000, and the wood next to it is 9,000. The lower leg of a mammoth is 15,000 years old, the skin is 21,000. 2 mammoths found side by side in Alaska, one is 16,000, one's 22,000. Which number is right? Living penguins carbon dated 8,000 years old. 11 human skeletons, the earliest known human remains in the Western Hemisphere, were dated by accelerator mass spectrometer. All 11 dated about 5,000 radiocarbon years. Lava from a 1801 Hawaiian lava flow was 1.6 million years old. Well, hello is not even 200. Another volcano erupted in Hawaii in 1959. When they dated the lava, it was 8.5 million years old. At least potassium argon dating for that, not carbon. Mount Etna in Sicily, I climbed Mount Etna when I was over there some time ago, erupted in 1972, 350,000 years old. Mount St. Helens built a new lava dome in 1982. They dated it, got numbers from 350,000 to 2.8 million. It's not even 20 years old. Here's what you ought to consider about carbon dating. Samples of known age, it doesn't work. If it's a sample of unknown age, it is assumed to work. That's stupid. In the last 2 years, an absolute date has been obtained for the Gandong beds above the Trenel beds. It has the very interesting value of 300,000 years, plus or minus 300,000 years. Boy, they nailed that one right on the head, didn't they? See, back in 1770, George Buffon said the Earth is 70,000 years old. 1905, the official age of the Earth was 2 billion. When they went to the moon, they said the Earth and the moon are 3.5 billion years old. 3.5 billion, dated with potassium argon dating. Now they're telling the students it's 4.6 billion years old. Let's see, that means the Earth is getting older at the rate of 21 million years per year. That's 40 years per minute. Aging rapidly, folks. That's stupid, okay? All they do is add more time to make the theory look more reasonable. Long ago and far away, And when you prove it couldn't happen, they say, well, it was longer ago and farther away.
O Timothy, keep that which is committed to thy trust, avoiding profane and vain babblings and oppositions of science, falsely so called, which some professing have erred concerning the faith.